Okay, welcome to the Dublin Academy of Maths. Now you get me at Gmail, dublinacademy@gmail.com. My name is Michael Dalton, and today we're doing the first set of the first Series 3, and it's Paper 1 and it's Calculus. Leaving Ord Ordinary Level Maths, Series 3, Episode 1, Paper 1 and it's Calculus. And today we're going to do differentiate each of the following with respect to x. Okay, and so I'll just let you have a look at this. Find the angle, find the slope. Okay, tan is the angle, we did this before. Now I'll get back and do these later on. So, what have we learned so far? Okay, what have we learned so far? We've learned that in graphs, cubic graphs, or any graph, we let f of x is equal to y. Right, so with respect to x. And this will come later for calculus. So y, the curve is represented with respect to x. In other words, the solutions are on the x value, on the x line. Okay. Now we can change a line. So everywhere we go, we now know that we can find the slope of a line at any point. Okay. Now some of those points you're familiar with. Maximum points, the slope is equal to 0. Minimum point. Okay. Slope is equal to 0. Okay. So in this case, we are walking along here, and the slope is going up, all right, and then you're going down, all right, and the slope is going down when you're going. So you just imagine yourself walking along here, okay, and you're going up. Now, so because of functions, we're able to identify lines in space and the direction and its slope. Okay, now that's very important when it comes to calculus. So really only when this could only reach a function so far as that it could tell you where things are in space. All right, and it has been part of celestial astronomy up until the last 100 years before Isaac Newton came along. Okay, now Isaac Newton. Well, let's look at this before we go on to Isaac Newton. So y is f of x is equal to y with respect to x. So the solutions are on the graph. You know that. You know just how to get a slope of a line. You can put in the form of y is equal to mx plus c, or use the slope formula. Okay, now this is very important. You've got two options here to find the slope of a line. Now on this so happens that the line will be able to tell you the slope of the curve at a certain point. Okay, at a certain point. We were able to translate functions, make functions one equal to the other, f of x equal to g of x, solve it. Okay, do you remember what do I need to add to fx to reflect g of x? Things like so, solving cubic equations. Other things that came, so along came this fella Newton, okay, who advanced mathematics, classical mathematics by unknown millennium, okay, he really what he did was when you see the tree and the apple falling out of the tree, what was that supposed to represent? Well, because the apple fell downwards, it represented, and it didn't fall outwards, it represented that there was some sort of force acting on this. Okay, and he called it gravitational force, and it is gravitational force. Now it was always, but he actually put it into, because he saw this drop, he was able to put it into a formula as such. Okay, into a formula, and he was able to derive all functions with this formula. Okay, this beautiful formula here, and really, so what he could do is not only could he tell you in time and space, but he could actually tell you the direction where the curve was actually going. Okay. So they were able to plot stars, and they were able to plot a lot of things. You know, this is not including astronomy. Also includes now with the switch you turn on your bedroom light at. You know, I mean, it's all to do with movements and force. Okay, so he was able to put everything down into a formula, and it was quite a good formula he put in. So he realized that. So we have this formula is derived from another formula, dy dx. Okay, now I'll explain, and then we have d squared y and dx squared. Okay, now there's this. We'll get to these later, but you get the idea. Remember that this formula is going to come up again. Alright, so he brought it down to Principia Mathematica. Okay, now in also doing that, he was the cause of someone's downfall as well. You know, he was a bit of a sociopath. Okay, now the fellow he brought down was another advanced fellow who was dealing with quantum mechanics, which was the precursor to Einstein's theories. So now you've got a general idea of what's happening here with the apple and how gravitational now is a force. Okay, and he identified that force. And okay, so now I'm going to start doing some questions here. We will have a look at this now. So I'm looking at this angle here. I'm told that I can't find the angle, and I've got 2 points here, 1, 0, 2, 1. Okay, now I can find, there's a few things I can do. I want to find the slope of that line. As I said before, find the slope, we'll call this L again. Okay, find slope of L. Okay, find slope of L. Now we can do two things. First of all, we write down the points 1, 0 and 2, 2. Right? We can find the slope by putting in the formula x1, y1. Label them first, sorry. And the formula is, for the slope of a line is y2 minus y1 over x2 minus x1. Okay, we slot the values in there for y. Okay, so y is 2. y2 minus y1 minus 0 over x2, which is 2, minus x1, which is 1, which is 2 over 1, which is 2. So it's a positive slope. Okay? Now, given the slope, I can find the angle. Okay? So given the slope, so tan of the angle, so tan theta is the same as y over x. Alright? It's the same as the y's over x. So if I'm told that tan theta is equal to 2 was the last one. Okay, we use our calculator. Right? And I don't know whether you're going to see it, but you will be able to zoom down this. You're free and zoom down, I'd imagine. So you go tan theta is equal to 2, so you have to inverse it. Tan 2 equals, okay, 63 degrees, right? Now, the theta at 63 degrees will give you a tan of 2. In other words, the angle is equal to 63 degrees. Now, so I'm given the slope, I can inverse it and bring it back and find the angle. And a lot of things are done like this as well. Like, for example, that was a kind of like tan of 1. Tan theta is equal to 1. Okay, so I do it again. Inverse tan 1 is equal to 45 degrees. Okay, 45 degrees is equal to tan 1. Okay, tan of 1, or tan is equal to 1. Okay, so tan of 45 degrees is equal to 1. Now, so if you were to find the tan of 45 degrees, which you don't know, you just do the reverse. You just press, instead of second function, you go tan 45 is equal to 1. The slope of that line is equal to 1. So if I'm told that the slope of this line is 45 degrees, I don't need to use this formula. I don't need to use these formula x2, y2 minus the y's over the x's. I don't need to do this. Okay, I can use my calculator. Okay, now getting on with finding another question to do. Okay, now I'm going to differentiate from first principles. Right, so Newton came up with this formula to calculate. And how did he come up with this formula? Well, he came up with this formula by by doing this. Okay, now I will explain it all to you now. So he's got the function, and he put in, everywhere he sees the function, he puts in x plus h. We've done this before, and then he minuses the function. Okay, now so from first principles, get some space. So, y is equal to 2x squared. And it says derived from first principles. Now once you see the word first principles, you know you have to use the long method. Okay, so there's two methods here, there's the long and the short method. Okay, so everywhere I see x, so y is equal to 2x squared. And I'm following this formula. So everywhere I see x, I put in x plus h. Okay? So dy dx is usually written as this. everywhere I see x, I put in x plus h. So that's x plus h to be squared. Okay? Minus f of x, which f of x is 2x squared. All over h. And you multiply this out. Okay, and you get, this multiplies out, you know how to do this, you do it on the side, okay? Because, so you're left with 4xh plus 2h squared minus 2x squared plus 2x squared. Okay? All over h. Now watch what I'm doing here. I'm cancelling the h's. Okay, so I'm cancelling this h with this h. I'm cancelling this h with this 2 h's up here, so I'm only left with 1 h. Okay, so it's 2h, h all over h, cancel, cancel, left with 2h. Minus x squared, 2x squared. And the answer is 4x plus 2h. Now, h goes to 0. The answer is, when h always goes to 0, I'll explain that again, the answer is 4x. Okay? That's how you do it by first principles. Now we might do a couple, we will do a lot of these again, but remember the formula, okay? Now the formula is also written in this form, n times x minus 1. So if I wanted to do it again, except I'm going to use this formula, I think I've done this before with you, I'm going to multiply by the power, okay? So this is the same formula as if you have a digit beside it like 2, you multiply by the n. Now this is on page 41 on your tables, I think it is. Yeah, 41 on your tables. Yeah, log tables. Right? Now 41 on your log tables. There it is there. Okay? You'll see it there. N times x to the power of n minus 1. So you know that now, and you know where it is for questions. So I multiply by the power, so 2 by the power, and I reduce the power by 1. Okay? Remember that. Okay, this is a bracket, so don't get too confused about that. So this is the answers to, so I've got 4x, 2 minus 1 is 1. 4x, the answer is 4x. Okay, like the same answer. And the derivative of a constant is always equal to 0. So if you had plus 4 here, the answer would be plus 0. Okay? The derivative of a constant, that's a number. Constant, gee, spelling is terrible, is equal to 0. Right, okay, so let's try another one. Okay. So we've got two methods here. Okay, that's over h. First principles and by rule. Okay, first principles and by rule. Don't remember, don't forget. Questions, practice, practice. So we've got y is equal to 2x. Y is equal to x squared plus 2x. Now, if I was to use the formula dy dx, the long formula, that means derived from first principles, every time I see x, I put in x plus h to be squared, plus 2 times x plus h, all over h. Okay, minus the f of x, so it's minus, don't forget now, put these in brackets, because if you have signs on them, you will have to sort them signs out. Now if I multiply this all along, it's going to give me a long equation, okay? So I'm just going to write out what it has given me. X squared plus 2xh. Now you should be doing this, plus h squared plus 2x plus 2h minus x squared minus 2. Minus 2x, I think. Yeah, minus 2x. All over h. And the same thing again, I cancel my h. So where is my h cancelled? There's a h there. Cancel the h there, the h with the squared, the h there, and I'm rewrite that equation out, and I've got x squared. X squared. They cancel out the x squared with the x squared cancels, so I'm left with minus 2x cancel with this. So I'm left with 2x. H is gone, plus h plus 2. Okay, h goes to 0. That means 0 for h, and you're left with 2x plus 2, and that's what it is. Okay, we'll do the short variant now, so it's 2x plus 2. Okay, so we'll do the next part here. If we were to do it the short way, y is equal to x squared plus 2x. Using the formula dy dx is equal to 2 times x minus 1 plus 2x. 1 minus 1 is 0. So left with 2x plus 2 to the x to the power of 0. Anything to the power of 0 is equal to 1, always. So left with 2x times plus 2 times 1 is equal to 2x plus 2. Okay, I hope you can see this. This green pen isn't the best, but you can follow it down there. Okay, now that seems okay. So remember, our good friend Newton was responsible for reducing motion quantum mechanics by 10 years and increasing classical science mathematics by over 100 years. So he was responsible for 2 things. But he's quite a genius. Now these questions here are differentiate with respect to x. So you're just using differentiate with respect to x. Okay, now I'm going to tell you to do this by both rules. By both rules. That's the long way and the short way. Okay, find the slope of this. Find the angle. So you're using your tans. That's 60, tan of 30, tan of 90, tan of 45. This one here is number 12, is tan of theta is equal to 1.7, tan of the angle theta is equal to 0.577, tan of the angle is equal to 5.6. Okay, don't forget Dublin Academy at Gmail. If you want to buy into the series is €20. You get support, that means you get anything related to this series. I will be able to answer questions. I have a one of those digital writers, so you'll be able to, I'll just do it anytime and I can send it down line, you know, by email. So I just write it out to digital, so they're very handy, very small tablets. That seems to be everything now. Okay, so don't get bogged down with calculus. All he was he was able to find the direction of a moving body, which led to an enormous amount of opening of doors for sciences. Okay, movement of water and all this speed and everything related to it. Okay, that was great. Thank you. Bye.